there's a place where giants go to die, sprawling across arid desert landscapes under a relentless sun. Thousands of passenger jets sit in silent, perfect rows. Their engines are wrapped. Their windows are silvered. Their massive bodies just baking in the dry heat. This is the airplane boneyard. From the air, it looks like a memorial, a final resting place for the titans of travel, the very machines of some that once connected our world. But this image, this idea of a graveyard, is a profound deception. These desolate fields are not graveyards. They are not monuments to decay. They are pulsating, high-tech, and incredibly profitable disassembly lines, operating on a scale that is almost impossible to comprehend. This is one of the best-kept secrets in modern industry. This isn't about crushing scrap metal. It's a precise surgical operation where over 90% of a 12,000-ton behemoth is resurrected in each one like that. What you're looking at is one of the world's most sophisticated and valuable recycling operations. A hidden multi-billion-dollar industry that keeps the global aviation network running. So, how did these deserts of forgotten engineering become gold mines? And what does this meticulous process of deconstruction reveal about the hidden economics and the uncomfortable truths behind the planes we fly in every single day? The answer is a story of material science, brutal economics, and a looming environmental paradox. First, we have to ask a fundamental question. Why does a machine worth hundreds of millions of dollars even end up here? Unlike a car, a plane doesn't just get old and break down. It's designed for an almost indefinite lifespan through constant part replacement. The truth is, planes don't die of old age. They are killed by economics. An aircraft's life is measured in pressurization cycles. Each time the fuselage is pressurized for high-altitude flight, it adds a tiny amount of stress. A typical jet is built for about $75,000 to 90,000 cycles, or 20 to 30 years of service. But that's the safety limit. The economic limit arrives much, much faster. The real executioner is its operating cost. A newer model, like a Boeing 787 Dreamliner, might burn 20 to 25% less fuel than the 767 it replaces. That doesn't sound like much, does it? But when jet fuel prices spike, the operating cost of that older jet skyrockets, making it a financial liability for an airline, even if it's perfectly safe to fly. Then there are the maintenance checks. Heavy maintenance, or D-checks, can cost millions of dollars and take the plane out of service for weeks. For an aging aircraft near the end of its profitable life, an airline will often run a simple calculation. Is the cost of this massive overhaul worth less than the revenue the plane will generate? Frequently, the answer is no. It's cheaper to retire the multi-million-dollar asset and buy a new one. And so, the call is made and the giant begins its... Once a plane lands in a boneyard, like the massive Pinal Air Park in Arizona, the clock starts ticking. The desert environment is crucial. Low humidity prevents corrosion, preserving the aircraft's value. The first step is triage. Is the plane being stored for a potential return to service?
Okay, everyone,
or is it destined for parts out?
Proceed with the ascent
If it's the latter,
Watch
a
your
team
footing.
of specialized engineers descends upon it. This is not a demolition crew, it's a surgical team. They begin by depolluting the Boneyards aircraft. Every single fluid, jet fuel, hydraulic fluid, and oil, is filtered and often resold. Then comes the high-value harvest. The engines, which can be worth up to $10 million each when they are meticulously removed. Well, no, they're not melted down. They're sent to specialized facilities to be recertified for use on other active aircraft, providing a lifeline for smaller airlines that can't afford brand new engines. Next is the landing gear. These complex assemblies of hydraulics and high-strength steel are engineered to withstand incredible forces. Like the engines, they are removed, overhauled, and certified for reuse, often selling for hundreds of thousands of dollars. The same goes for the avionics in the cockpit. These components, the plane's brain, are a treasure trove of electronics, each one catalogued, tested, and placed into a global secondary market. This entire process is managed by a sophisticated digital nervous system. Every single component, from a massive engine turbine to a single specialized screw, is tagged, photographed, and entered into a database. This creates a global marketplace, a kind of eBay for titans, where an airline in Indonesia can source a certified flap actuators and revenue from a retired A320 sitting in the Mojave Desert and have it shipped overnight. It's the circulatory system of a $5 billion a year industry built on the bones of retired giants. After the high-value components are harvested, the real material science begins. The remaining airframe looks like a hollowed out. Now, a common misconception is that this is just a pile of aluminum. In reality, it's a complex cocktail of advanced alloys that cannot simply be melted together. The fuselage is primarily made of alloys like 2024 aluminum mixed with copper for strength, while the wings use 7075 aluminum mixed with zinc for superior stress resistance. You see the problem? If you melt these together, you get a weak, useless hybrid. So, teams use schematics of the aircraft to literally cut it apart along the lines where different alloys meet. Giant hydraulic shears slice through the fuselage, separating sections with clinical precision. These sections are then sorted and sent to specialized smelters that can process aerospace-grade alloys, preserving their unique properties for reuse in other high-performance applications, from automotive parts to new construction material. This is a far cry from recycling an aluminum can, and the value extraction goes even deeper. The wiring and electronic components contain precious metals. This is true urban mining. Specialized firms now exist that can process this e-waste to extract trace amounts of gold, silver, palladium, and rare earth elements like neodymium from the plane's countless microchips and actuators. Every gram of value is meticulously wrung out, leaving almost nothing to waste. The final 10%, seats, insulation, plastics, is often the only part that ends up in a landfill. This incredible system, it seems like a perfect model of a circular economy, right? It reduces the need to mine new bauxite for aluminum. It lowers manufacturing emissions. And it provides a supply of affordable, certified parts that reduces maintenance costs for airlines. This, in turn, can help to keep airfares down. It's an economic and environmental win-win, right? Well, this is where the story gets complicated. The very efficiency of this used parts market creates a powerful, counterintuitive incentive to keep older, less fuel-efficient aircraft flying for longer. Why would a small cargo airline invest $100 million in a brand new, fuel-sipping plane when it can keep its 25-year-old Boeing 757 in the air cheaply, thanks to a constant supply of recertified parts from the Boneyard? The system that is so good at recycling material is simultaneously extending the life of technology that is less sustainable from a carbon emissions perspective. This creates a direct tension. On one hand, we are reusing physical resources with near-perfect efficiency. On the other, we are potentially slowing the adoption of newer, cleaner engine and airframe technologies. The Boneyard, therefore, isn't just a solution. It's also part of a complex environmental problem. It forces us to ask a difficult question. What is the true definition of sustainability in aviation? Is it recycling the old, or is it accelerating the new? Furthermore, the reliance on used parts hinges on an unbreakable chain of trust and regulation. Every single component must be rigorously inspected, tested, and documented to standards set by bodies like the FAA and EASA. The system works because the paper trail is flawless. But as these components are reused multiple times, questions of long-term metal fatigue, an ultimate lifespan, become more pressing. It's a system built on incredible engineering and trust, but one that operates under constant scrutiny to ensure that economic efficiency, it never compromises safety. So when we look out across those silent rows of jets in the desert, we should see them for what they truly are. They are not tombstones. They are a crossroads. They represent the precise point where the life cycle of one massive piece of technology ends, and the lives of 1,000 others are extended. They are a monument to our ability to deconstruct and reuse, a testament to the value we can harvest from what appears to be waste. But they are also a mirror, reflecting a deep and challenging paradox in our quest for sustainability. They are a physical manifestation of the battle between economic efficiency and environmental progress. The Boneyard solves one problem, our consumption of raw materials, while potentially exacerbating another, our carbon footprint. The existence of this $5 billion industry proves we can be incredibly smart about recycling the past. The real question is whether we can be wise enough to design the future. Will the next generation of aircraft be designed from the start for easy disassembly and reuse? Will new business models emerge that prioritize whole life cycle sustainability over short-term operating costs? The answers to those questions will determine the future of flight. Until then, the giants will continue to fly to the desert, not to die on, but to be reborn, piece by valuable piece. These are not graveyards. They are high-tech, profitable disassembly lines. Planes are killed by economics B. A newer model might be 25% more fuel efficient. The high-value harvest begins with the engines, worth millions each. Every part, down to a single screw, is catalogued in a global database. Different alloys in the fuselage and wings cannot be melted together. So, giant shears cut the airframe apart based on a digital schematic. This seems like a perfect circular economy, reducing waste and cost. But the paradox is that cheap parts keep older, less efficient planes flying longer. This creates a tension between recycling material and accelerating cleaner technology. The Boneyard is a crossroads, the end of one life cycle, the extension of thousands more. They are not tombstones, but a monument to rebirth, piece by valuable piece.